Let's get started. I would like to introduce Kaizen's own Joe McChesney.
Good morning, and welcome to today's event. My name is Joe McChesney, and I hope the information you receive today will benefit you. Today we're going to discuss how are you cleaning Krytox. Krytox is the Chemours brand name for a range of synthetic lubricating materials for a wide range of applications. The typical compounds are composed of carbon, oxygen, and fluorine. And there's a lot of different compounds, lubrications, and greases in this family, and they do vary by products. If you look on the left, you'll see the DuPont Krytox 240AC. This is the most preferred product for aerospace applications. And Krytox oils and greases do not contain any silicones. Krytox lubricants have become the product of choice for the aerospace. They perform in extremely high or low temperatures. They're non-flammable for oxygen compatibility and are resistant to aggressive chemicals. This all makes them a very good choice for sealants and lubricants. But they're not only for aerospace. Automotive, for example, your windshield wiper motor gears, your sunroofs, your oil pressure sensors, your wheel bearings, your throwout bearings if you drive a strict stick shift. A lot of different uses in automotive. Medical, same thing. For oxygen line tubing fittings, compressions, O-ring lubrications, pump seals, diaphragms, Krytox is used extensively there. Aviation, another good choice. For fuel line sealant, high pressure sealant, all types of actuators for ailerons, landing gears, etc. Krytox does not deteriorate over a long period of time, and it's an excellent lubrication and sealant. Nuclear, same way with the high pressure lines. The coolant pumps, most of them have Krytox lubricant on their seals and diaphragms and O-rings. All the pumps and valves, motorized actuators, Krytox is the preferred sealant for that point. And also even electronics, the disk drives, even the doors, the little floppy disk drive doors, which is disappearing, they actually have lubrication of Krytox in that to keep it running, and it doesn't spread throughout the system. It stays where it's applied. Krytox oils and greases are the preferred choice for multiple applications for more than 40 years because they're chemically inert, they're thermally stable, moisture resistant, excellent lubrication and sealant capacities, they're non-flammable, and they're safe. And if you look at the text fact box, most common lubricants can self-ignite under high compression if they encounter oxygen-rich atmospheres, causing extremely dangerous situations. This is where Krytox is really good. It is compatible with oxygen and will not self-ignite. So why clean Krytox? Well, once it's been applied, such as in periodic service intervals, you have to remove it to service the equipment that it's in, whether it's pumps, seals, actuators, gears, etc. It has to be serviced. Ongoing lubrication, especially for high-end pumps, nuclear cooling pumps, process fuel line pumps, etc. Ongoing lubrication requires Krytox to be applied, and sometimes you have to take the pumps apart to do this, and that way you apply new Krytox. Parts replacement. If you have a motorized valve fail or actuator fail, or even like a warranty situation on your car, your windshield wiper motor fails, they have to take those parts out, and if it's a fuel line or oil pressure sensor, they reseal that with new Krytox when they put it back together. Equipment upgrades. If things change and there's a different model or a more improved factor, they have to take out the old stuff such as pressure regulators, pumps, diaphragms, etc. And that gets upgraded, so that means that the old Krytox has to come off the lines as you take them off and put the new lines back together to the equipment. Required MRO. This is huge in military, aerospace, and even medical. After so many hours of operation, things are disassembled. The components are taken down, the lines are removed, sometimes the lines are flushed. They basically are resealed and put back in, so MRO is a huge operation where Krytox is very important. OEM components rework. A lot of these valves are specialized in the oil industry and even nuclear. These are custom built systems, and when they put them together, if they don't work properly the first time and don't seal or they don't meet the pressure ratings, they have to tear them down and rework them. They don't scrap these items because the cost is so much. They simply rework. Therefore, the Krytox must be removed that was once applied to the original job. And there's a lot of other applications where Krytox has to be removed before it can be the part can be reused. It's great stuff, but it's hard to clean. All the outstanding qualities that make these materials also make them challenging to remove when required. Its inertness to chemical attack also makes it insoluble in most common solvents and why it cannot be washed out with water. Likes remove likes. This is an old saying that's true today. Krytox products are fluorocarbon based. Therefore, it takes a fluorinated solvent that makes it easiest to provide quick and effective removal from the parts. Fluorinated solvents, most of them are non-flammable. They're compatible with a wide range of materials, metals, and elastomers. They offer rapid evaporation with minimum non-volatile residue. And the non-volatile residue is huge in aerospace and aviation and nuclear. Fluorinated solvents can remove Krytox and generally not affect any components or the performance of those components once it's been removed. So how do you clean the Krytox? There's several ways to remove Krytox, but the three most common methods are: 1. Manual scrubbing. This is where you apply the solvent to the target area where the Krytox is at. Use a brush to remove the Krytox from the surface until an acceptable cleaning level is achieved. Following scrubbing, you may have to use a wipe to remove any final films or residue. And always remember to properly dispose of the removed soils and debris. The second method is spray impingement, and this is becoming the more common type. You apply the solvent using a low-pressure spray gun to displace the Krytox from surfaces until you reach the acceptable cleaning levels. You always spray inside a liquid-tight container and always use proper personnel protection equipment. Spray impingement and the solvency of the fluorinated solvents combined will remove the Krytox from the parts generally pretty quickly. And I have some examples here. These are actual photos of NASA parts. These are fittings that were taken from different locations. And I know it's hard to see, but if you look, you'll see a little bit of the white Krytox residue and film. And all these parts, before they're reassembled, have to be cleaned inside and out. Typically, before they would put the solvent in a pan, they would take a brush, and this technician is a NASA technician. He would scrub those parts, and he would keep rotating and manually scrub them until he got it clean. Now, in this test, they basically have the parts. You can see where the Krytox lubricant residue is left. He's using a low-pressure manual spray gun, and he's applying the Krytox directly to the fitting. Next spray, he's continuing to spray. And now you can start to see bits and pieces of the Krytox that's been displaced inside the containment pan. It keeps building, it keeps rotating the parts, and this has only taken a few minutes. At that point, the part is cleaned. They check these parts and the acceptable level, cleanliness level, is met their final end run. The third step is immersion in boiling solvent, and this is still used today. People use a typical vapor degreaser with a fluorinated solvent. This is after the components have been disassembled and they put them in a work basket to go inside a vapor degreaser. The solvent turbulation created by the boiling action inside the degreaser boil chamber will dissolve and displace the Krytox from the parts. Think of a jacuzzi, because the boiling action, and you'll see it in the video following, it's like a jacuzzi action that actually moves across and around and through the parts and displaces the Krytox. After the soils have been removed, you can take those soils out of the degreaser through a standard distillation system, and that extends the bath life and improves the purity of the solvent for the next load. Again, the first stage is the cleaning stage. You're immersing the parts in boiling solvent. In this particular video and this particular machine, supplemental mechanical action by vertical jogging is added to help speed up the process and make it a more thorough cleaning. You can see the product going down inside the vapor degreaser into the boil chamber. You can see the turbulation of the boiling solvent, and you can see the mechanical action of the stroking up and down, which is displacing the solvent in and out, and also it removes the contaminants off the products. After that stage is done, now you've got the parts washed. You want to rinse them in a cleaner grade solvent to displace any of the dirty solvents that's left on it, and also maybe any residual contaminants that's left on the product. So at this point, the parts are moved over to a cleaner grade tank of solvent, and they're submerged. Most people use ultrasonics at this point to create mechanical action, which drives off the contaminants from the parts and goes into the degreaser. The parts then exit clean and dry. When you consider any solvent, most desirable qualities for EH&S have to come first. You want a solvent that's non-flammable as per ASTM specifications. You want a high wetting index. You want low surface tension. You want VOC exempt if possible. You want a low global warming potential, high operator exposure limits, an OEL or could be called ppm limits, multiple metals capability, and you want something that has no additives and stabilizers because the stabilizers and additives could become flammable. And you want something that's energy efficient. And most of all, you want a solvent that is approved by the EPA and OSHA. All of these are desirable qualities, and you can generally find these in various different forms. So in summary, there are various ways to clean Krytox, but the most important step is chemistry first. Prior to selecting any cleaning operation, it is important to address the desired results that you want on your end tube. How clean are the parts? Do they meet my levels? Chemistry to be used. Does it meet the current EH&S specifications? Does it fit my type of process I'm going to use? Is it safe for my personnel? Is it safe for the atmosphere? Waste treatment required. After you remove the contaminants, you must dispose of those contaminants, and probably there will be some solvent in with that. So you want something that's easy to dispose of and meets all local codes. And environmental compliance is probably one of the hugest in today's world. Is it a VOC? Is it a low global warmer? Is it meet the personnel exposure limits? Because without the right chemistry, you will face difficulty in achieving your goals. And there's a lot of expert help available in the market today. And with that, I'm going to turn it back over to William.
Thanks, Joe. If you would like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.